Welcome to Chapter 6, Operators and Operands. In this chapter, we will learn how to manipulate data. We start with arithmetic operators, which are symbols used to perform mathematical operations like addition, subtraction, multiplication, and division. 1. Basic operations. Python supports the standard 4 operations. A key thing to note is that the division operator, the /, always returns a float, even if the result is a whole number. 2. Modulus and floor division. Often you need integer results or remainders. The floor division operator, /, rounds the result down to the nearest whole number. The modulus operator, %, gives you the remainder. 3. Exponentiation. Finally, to raise a number to a power, Python uses the ** operator. Do not use the caret symbol, as that performs a bitwise operation. To summarize, Python provides a complete set of arithmetic operators. Remember that / is for float division, / is for integer division, and * is for exponents. Now that we can perform math, we need to learn how to store the results back into variables. Join me in Lecture 06-02, Assignment Operators. Welcome back. We know how to calculate values, but calculations are useless if we don't save the results. Assignment operators are used to assign values to variables. Beyond the basic equals sign, Python offers compound operators to perform an operation and assignment in one step. 1. The basic assignment. The single equals sign is the fundamental assignment operator. It takes the value on the right and stores it in the variable on the left. 2. Compound assignment operators. Python allows you to combine an arithmetic operation with assignment. For example, plus equals adds a value to the variable and updates the variable with the new result. This shorthand works for all arithmetic operators: subtraction, multiplication, division, and even modulus. To summarize, compound assignment operators make your code cleaner and easier to read. Instead of writing x equals x plus 1, you can simply write x plus equals 1. Now that we can change values, we need to know how to compare them. Join me in Lecture 06-03, Comparison Operators. Welcome back. Comparison operators, or relational operators, are essential for control flow. They allow your program to make decisions by comparing two operands. Crucially, the result of any comparison operation is always a Boolean value, either true or false. 1. Equality and inequality. The most frequent comparison is checking if two values are equal, using the = sign, and checking if they are not equal, using the exclamation mark followed by the equal sign. 2. Greater than and less than. We use the familiar mathematical symbols for checking magnitude, including the combined operators for greater than or equal to and less than or equal to. Python is unique in allowing comparison chaining, which is a concise way to check if a value falls within a range. 3. Comparison with different types. You can compare different numeric types without issue, as Python handles the type conversion. String comparisons are based on alphabetical order, derived from the Unicode value of the characters. To summarize, comparison operators are the workhorse for logic, always yielding a Boolean result. Be mindful of the difference between the assignment operator, single equals, and the equality comparison operator, double equals. We can now compare single values. Our next lecture, 0604. Logical operators. See you there. Welcome back. Logical operators are the heart of decision-making in any programming language. They allow you to combine multiple comparison results or reverse a Boolean value. Python uses the keywords and, or, and not for these operations. 1. The AND operator. The AND operator returns true only if both operands, the left side and the right side, are true. If either is false, the entire expression is false. 2. The OR operator. The OR operator is more forgiving. It returns true if at least one of the operands is true. It only returns false if both operands are false. 3. The NOT operator. The NOT operator is a unary operator, meaning it only takes one operand. It simply reverses the logical state of its operand, turning true into false and false into true. To summarize, logical operators are one piece of the puzzle for building complex logical conditions. Remember that AND requires strict compliance, while OR allows for flexibility. We have learned the fundamental operators. In our next lecture, 0605, Operators BMI Usecase. We will now put our knowledge of arithmetic and logical operators to work with a practical example, calculating the body mass index, or BMI. The BMI is calculated by taking weight in kilograms divided by the square of height in meters. 1. Arithmetic calculation. First, we define our inputs for weight and height. Then, we calculate the BMI using the division operator and the exponentiation operator. 2. Logical classification. Now we use comparison and logical operators to determine the category. The normal weight range is generally between 18.5 and less than 25. We use the AND operator to check both boundary conditions. We can similarly check for other categories, like if the person is underweight, which uses the less than operator. To summarize, we combined arithmetic operators for calculation and comparison operators with the AND logical operator to classify the result, demonstrating a real-world application of the concepts in this chapter. This concludes our chapter on operators and operands. We now move to Chapter 7, Input and Output Functions. Join me in Lecture 07-01, Introduction.